All right. So we've learned how to name acids, hopefully. If you haven't, you can go back and watch that section on how to name acids. And here's a little review for us, a couple more reviews for naming acids. Let's see. What do you think here, Fred? What do you got?
I did kind of forget how to name the acids. Can you help me a little bit?
Okay, so there was two types of acids. Do you remember the two types of acids?
Oh yeah, Oxo Acids and they're the ones that have oxygen in them, and the other one, I can't remember.
The other ones are element or compounds, acids that only have two types of elements in them. So, and one of them is always hydrogen, right? So hydrogen HCl is an example of this type. It's called a binary acid. HBr, right? Just one kind of element other than hydrogen. You can have two of those elements, H2S, that's another example, right? But these are binary acids, and they're named following this model, hydroblankic acid.
Yeah, I know HCl. HCl is hydrochloric acid.
That's a great model. That's a great model to have, because if you always remember HCl, and if you can recall that there's two different acid naming types, binary and oxyacid, then you'll remind yourself how to name the binary acids by thinking of the name of hydrochloric acid, hydroblankic acid.
Okay, so how do you name the other kind?
Well, we have the ClO3, which is a polyatomic ion. And it will always be hydrogen with a polyatomic ion in the oxo acid style, right? So we just look at the name of that polyatomic ion.
That's chlorate.
Very good. And because the polyatomic ion ends in 8, so the ClO3, that's chlorate, right?
Yeah.
So the ClO3 ends in 8, chlor8, then 8 goes to ic. So the kind of acid is chloric acid, and there's no hydro anything, it's just chloric acid.
Okay, got it.
Very good. So here's another one. Oxyacid or binary acid?
Oxo acid.
That's right, oxo acid. So we look at the polyatomic ion name. Do you know the name of SO3?
That's not sulfate, SO4 sulfate. Let me check. Okay, it's sulfite. SO3 is sulfite.
Very good. As a side note, do you know the charge on the sulfite?
Let me look. Oh no.
Don't look.
What?
I want to see if you can tell without looking what the charge is.
Oh yeah, because it has two hydrogens, it must be a -2.
That's right, very good. So this is the sulfite ion, sulfite. Now, 8, if the polyatomic ion ends in 8, it goes to ic, but if it ends in ite, it goes to us. So this is, which one of these is that?
Oh, sulfurous acid.
Very good, sulfurous acid. Fabulous job. All right. Now we want to make sure that we are capable of writing the ionization of acids, either strong or weak, and bases, either strong or weak, with water. All right. We want to know how they ionize, how they do what they do. Now, what is the definition of an acid? An acid does what when it's placed into water?
It ionizes to release the hydrogen ion.
Very good. And what does a base do in water?
It results in the hydroxide ion.
Very good. Results in the hydroxide ion. You have to say results in the hydroxide ion because weak bases don't dissociate to release the hydroxide ion. They have a different model, right? And so let's look at these models. A weak base, CH3NH2. Now, it's very nice of them, and they'll generally always say, this weak base, blah, 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 how does it dissociate in the presence of water? How does it react when placed in water? Okay? And this is what our weak bases do, right? We have CH3NH2. We can write that. And whenever we're writing the reaction of a weak base with water, its dissociation reaction, so to speak, we have to have a water molecule. You have to have a water molecule because, do you remember what weak bases do with those water molecules?
You need to draw a second arrow.
What?
You need to draw a second arrow.
Oh, for this one? Yeah, okay, that's right. Because why? Why do we need that second arrow?
Because that shows us it's weak. I remember that.
Very good. Okay, so now back to this. How does this CH3NH2 react with water? What does it do when it reacts with water?
I can't remember.
Well, we know it's a base, so what does that mean one of the products are?
The hydroxide ion.
Very good. Because it's a base, we know that the hydroxide ion is going to be there. And how do you think that arises from this?
I can't tell.
Well, the water molecule is, if you remember, the combination of H plus ion, H plus ion, plus the OH minus ion, right? Those come together to form water. So that H plus ion, if it's removed, it results in the hydroxide ion. So the NH2 here, this portion, is going to grab that hydrogen from the water, CH3NH3, so it gets one more hydrogen, and it results in a positive charge too because of the extra electron or the electron that's left behind when the proton is removed. Okay, so that is how you write the dissociation of a weak acid. Okay, very good. Let's show that one. Let's go on to the next one, okay?
Why did you not put the hydrogen with the hydrogens on the carbon? Is that okay to do that way too?
That's a good question. So why did we put like CH4NH2?
Yeah.
Yeah, you can't do that because, now the reason is because of the way the chemical is structured, all right? We don't know enough about this chemical really to understand how it's behaving yet, and we won't really learn that until we get into maybe chapter 10, but more likely organic chemistry. So what we tell students up front is that the nitrogen is the place where the hydrogen always comes on or off at. And you won't generally find yourself in a situation where you have to identify between whether the hydrogen is with the carbon or the nitrogen. Okay? Good question. Now, let's draw how a weak acid dissociates. How does a weak acid dissociate? Well, weak acids dissociate. There's two ways to write it. Two ways, right? You can just write the weak acid, HNO2, and then what do I write as its products?
You need a second arrow first.
Oh, second arrow. Okay, that's good. We can do that.
It's acid, so H plus ion.
Very good. H plus ion. And that's helps us remember if it's an acid, H plus ion. Therefore, the rest, what's the rest?
NO2 minus.
That's right, NO2 minus. All right, now, so you're into big double or second arrow. What does that double arrows mean?
It's telling us that the products, H plus and the NO2 minus, come back together really, really quickly.
Yeah, it's right. It's saying basically that at what we call equilibrium, when these are coming back together and some others of these are dissociating, at equilibrium, there's a lot more this than there is these. And that's the definition of a weak acid. A weak acid is an acid that doesn't dissociate very much, whereas a strong acid, complete dissociation. Did you write down the strong acids on your chart like I asked you to?
Yeah.
Do you think there's some folks at home that forgot to do that?
Yeah.
Okay, so should we give them the strong acids, the list of strong acids to write on their periodic table?
Okay.
All right, so why don't you tell me, what are the strong acids that you have on your polyatomic ion or your periodic table? Strong acids, what are they?
I don't know if I can name them.
Sure you can.
Well, I know their chemical formula, but I don't know the names.
Well, do your best.
Okay. HCl, that is hydrochloric, I know that one. Then HBr, that is hydrobromic.
Hydrobromic, very good.
HI, hydroiodinic.
Hydroiodic.
Okay. Now we have, those are our only binary acids that are strong.
Oh, that's good. Good recognition.
Now we have oxo acids. We have HNO3. That's the nitrate ion with a hydrogen. So nitrate goes to nitric acid.
Very good. What's the next one?
HClO3. We just saw that one before. That's chloric acid.
Very good. What's the other one?
HClO4. That's, let me look at my polyatomic ion chart. Oh, that's perchloric ion, or perchlorate ion. 8 goes to ic, so it's perchloric acid.
Very good. We're just missing one now. What's the last one?
H2SO4. That is sulfate. 8 goes to ic. Sulfic acid.
Okay, it's actually sulfuric acid.
Sulfuric acid.
Yes, sulfuric acid. Very good. And the two strong acids that I ask people to kind of memorize, because most of the people have them memorized, is HCl, hydrochloric acid, and H2SO4, sulfuric acid. And by memorizing those, what that allows us to do is it allows us to, again, have a two model acids to remember how to name our binary and how to name any oxo acids as well. So our weak acid, HNO2, is going to dissociate like this. Now there's another way that we can write the dissociation of any acid, weak or strong, and that is where we include the water molecule. HNO2 plus a water molecule. All right. So now the weak acid, 2 arrows, right?
Yeah, 2 arrows.
All right. Now, what's different when I include the water molecule?
You just write H3O plus instead of H plus.
That's right. H3O plus. And what that is saying is that that hydrogen ion that's released is on a water molecule. Okay? And it is, but not very long, right? It moves so fast onto the next water molecule. So it's really just kind of bouncing around amongst all the water molecules as it moves. And the rest of the acid, what's left behind if you get the H plus ion to go with the water molecule?
NO2 minus.
Very good. Okay. The rest, or this NO2 also doesn't come back together with the same proton necessarily. It separates, HNO2 separates, leaves behind a proton with the water molecule and creates NO2. But this NO2 minus then just takes a proton from any other water molecule it sees. So there's lots of water molecules. There might be very few amounts of H3Os around in solution. And I mean, your concentration might be low. Therefore, it might be hard to find the one that you dropped off. But it doesn't matter. It just pulls it from some other water molecule, and the hydrogen bounces around, equilibrates around. Okay, so that is our dissociation of our weak acid. Okay, now a strong acid, it's exactly the same as the weak acid, but with a single arrow, right? Good. And then a strong base. Now a strong base, our strong bases are going to be our metal, group 1A metal hydroxides, or calcium, strontium, and barium. So here we have strontium hydroxide, and if we, where would I look to find out if this is a soluble compound?
Oh, the back of your periodic table.
Right, what do we call that?
Yeah, that thing. Not that one, but the other one. Yeah, there you go. The solubility rules, the ionic compound solubility rules.
Very good. So here I have our solubility rules. And group rule 5 here says that hydroxide containing compounds are generally insoluble except for a few exceptions. And those exceptions are our strong acids. So to draw those dissociating, you just draw the strontium hydroxide dissociating into its ions, and that is how we draw the strong base dissociating. Okay, good job. Did you learn something?
Yeah, I think I got how to name the acids.
Very good.